All right, so the problem, the mass balance problem that should be in front of you, if you don't have it in front of you, I'm gonna put it in the description below me. But this is a bit more complicated mass problem than your mass balance problem than the previous couple. The previous couple were they're pretty simple. This one's a bit more complicated, and then after this, there'll be more complicated ones that involve cell growth. But these don't account for cell growth, so they're still a little bit easier. So for this, we're doing a mass balance exercise involving the conversion of ethanol to acetic acid, which is vinegar. So ethanol is C2H5OH plus O2 converts to C3H3, no, it's CH3COOH plus water, I believe. Yeah, so one thing that's going to be different, so in the future when you do stoichiometric problems like this, they usually have subscripts in front of these, and you have to figure out, relatively speaking, the amount of moles in relation to each other. But thankfully, if you count all the carbons, hydrogens, and oxygens, this is all 1-to-1. So this is 1 mole of this and 1 mole of this is equal to 1 mole of this and 1 mole of this. In the future, when you do more complicated ones, it's not going to be that simple, but thankfully for this it is, which will make solving this a bit more simple. So first, this is our reaction tank. We have a stream of air going in, which is, let's see, 23.3% oxygen, and then the rest is hydrogen. Also, we have pure 100% ethanol going in. Also, for the air, our mass is 5.768 kilograms per hour. I'm going to do everything for this one, this process, it takes place over the course of an hour. So even though everything is in per hour, I'm just going to put kilograms and then just add in the hour at the end, since you don't really have to do that since it's only a 1 hour long process. So I'm just going to put kilograms for ethanol, for mass, we don't know. I'll leave a bit room for one more arrow later, so we're going to need one more arrow. And then our reaction, I don't know, it's supposed to be a reaction. Something like that, I don't know. That's a reaction. And then what we're left over with, we have something left over in it, but I'm going to model it as something leaving the system to make things easier. So what we're left with, which will be leaving, that's our product, is water and acetic acid. Call acetic acid AA plus water, and the acetic acid, it's 12% acetic acid. Yeah. Since it's going to be at most 12%, and since we usually want to drive as much product as possible in our process, we're going to model it as the max amount we can have, which will be 12%. Which means for water, it's going to be, I believe, 88%. Yeah. And then based upon the problem, which shows that there's going to be off gas, there will be gas leaving, which will have some percentage oxygen and some percentage nitrogen. So the first part is, what is the minimum amount of ethanol required for feeding this to convert it to acetic acid? So basically what our production target is, for the acetic acid also we know that it's going to be 2 kilograms, which means 2 kilograms for the first one, 2 kilograms of acetic acid. We're going to convert that to moles. So for acetic acid, that is 1 mole divided by, so acetic acid, it's 60 grams per mole, which means it's about 0.06 kilograms per mole. The molar masses on side are in grams, so you have to make sure you do them in kilograms unless you want to do a bunch of extra conversions. So it's going to be so it's going to be 0.06 kilograms per mole, or per kilo, no, 1 mole per 0.06 kilograms of acetic acid, which gives you 33.3 moles of acetic acid. This is important because this is all a one-to-one process. So basically what our process is doing is we're creating 33.3 moles of acetic acid, which means that every part of this reaction requires 33.3 moles, since everything's one-to-one, which will be important to know for later. Which means that if we're trying to make 33.3 moles of acetic acid, we're going to need 33.3 moles of ethanol. So 33.3 moles ethanol times, so the molar mass of ethanol is 46 grams, so it's going to be 0.046 kilograms per mole, which equals, this equals 1.533 kilograms of ethanol. So that's the answer to the first one. For the second one, we need to figure out what the minimum amount of water needs to be added in order to dilute it to 12, to make sure that it doesn't go above 12% acetic acid. This implies that our reaction in itself, because the reaction does create water, but this implies that it's not creating enough water. So we're going to have another stream that goes in that's water. Out of the water. But if we go off of mass balance, basically let me see. So the water total coming out is going to be equal to the amount created by the reaction, whatever amount is created by the reaction here, plus whatever's going in. So we're going to have, let's just call this WA for water added, plus WR for water from the reaction, which is equal to WT, which is water total. So here, our water added, this is what we're looking for. So it's going to be water total minus the water from the reaction is equal to water added. For the water total, we know the water total. So our product, which has water in it, our product that has water in it, is, since it's 12% acetic acid, that means it's going to be 88%. It's going to be 88% water. So this is going to be, hang on, let me